So hello and good morning dear students. I hope you all are enjoying maths class, and I wish that you enjoy mathematics. You love mathematics throughout your life. Alright. So our topic for today's lecture is invertible function, which is going to be very important for you in the upcoming chapter, which is the very next chapter. I mean to say, that is inverse trigonometric function. Okay, so to start that chapter, first you need to understand invertible functions. Okay, so let's start with the introduction which I want to give you for this topic. Invertible functions. What do you mean by invertible? The thing which can be inverted. Okay, you know, this invertible functions or the inverse functions have a very different impact in mathematics. You know, from the very starting, in the childhood also, you started the mathematics with some basic tools like addition, subtraction, multiplication and division. You can see the inverse thing there. How? For every addition, you know, you have subtraction. For every multiplication, you have division. So can you see the inverse relation between them? You know, in this 12th class, everywhere you will see, if you have something particular thing, its inverse can be seen in the parallel world. Like let me take one example. For matrices, you have inverted the matrix. You know, that inversion and this inversion is totally different. They both are different concept, but I'm trying to give you a sense that in mathematics, to every operation, to everything, there is a invertible function or inversion. Differentiation, if the function can be differentiated, it can again be integrated. So that is what inverse process, right? So that is how I'm giving you an introduction regarding this. Now, say for example, first let's see the definition of invertible function. See, the very important thing which you have to keep in mind for the function which is to be invertible, and that thing is 1 1 and onto. These two are very important words in the invertible function, or we say bijection. Bijection says if any function is 1 1 and onto, it is a bijective function. So invertible. So first let us understand 1 1. So for example, A, B, C, it has image 1 2 3. So this is a 1 1 function, and we know what is a onto function. That means the image has certain elements also. So it is going from here to here, and it is also, we are saying that it is going from here to here. So if you have two functions, it is going from here to here and here to here. So they are actually inversion, we can say. We are actually seeing the inversion here. So as I told you, that for a function to be invertible, there has to be 1 1 and onto. Are you getting this? Okay, so this is the foremost condition for the function to be the invertible one. Now let me give you an example. As I told you that in the next chapter we will see inverse trigonometric functions. So from there you have to understand that the trigonometric functions, the 6 trigonometric functions, has the potential to invert itself. Okay, so that is why their inverse is possible, and one chapter has been written for that one. Okay, so let's dive into this topic more. So if you have y is equal to fx as a function, so y is a function of x. This is read as this one, and x and y, they are the elements which we are taking from the two x and y set. Say for example, okay, and if we are defining a function as y equal to fx, then its invert will be, this f will be inverted, and we write f inverse of y is equal to x. If y is equal to fx and this function is 1 1 and onto, that means its inverse is possible. And how to denote that? So f is inverted, it is taken here, so f inverse of y will be equal to x. So that is how we denote the invertible functions. Now I want you to read the definition. 2-3 definitions are given in the book. Please write them. Write one example also. Now let's see the properties of invertible function. There are certain properties. The very first property says, as I already told you, that the function should be a bijective function. Then the next one, bijective function, I am writing here. Okay. F inverse of inverse will give you f, as we have seen in matrix also. The invert of the inverted matrix you will get a matrix. That means A inverse of inverse will give you A. Okay. Then let's see the next property. F inverse of f, you will get a identity function, and G inverse of G, no, f of f inverse is also the identity function of the. So they are saying that if there is one function from A to B, that means if this is A and if this is B, okay, so f inverse of f, this is a composite function, we will get an identity function, and f of f inverse also will get IB, which is a identity function of this B. Yes, if you have G of f the whole inverse, then this is equivalent to f inverse of G inverse. You know, we have seen in the matrices the property that if AB inverse is given, then it is equivalent to B inverse into A inverse. Isn't this two matching? That G of f the whole inverse is equivalent to f inverse of G inverse. Okay. All right. Then see one more. See in the definition, you know, it's given domain of f inverse is equal to range of f, and range of f inverse is equal to domain of f. So these two lines are very important. Please write this in your fair copy. Okay. Now that's it for the basic part. Let's start with the questions now. Okay. So let's understand them. Okay. So here we have the 1.5 first question I am taking. Let's understand from the starting. F is such that 1, 2, 3 is in A, B, C, which means they are A, B, C. Now there is a relation which is given to us. F1 is A, that means 1 is related to A with some function. F2 is B, so 2 is related to B, and F3 is C, so 3 is related to C. We made a small diagram here just to understand it very properly. Now the first question, to show f is invertible and find f inverse. So how can we show that f is invertible and we can hence find f inverse? So from this mapping also, if you draw this mapping, this will clearly depicts that for different elements in this set has a different images in this one. So if you consider this is x and this is y, so different element in this x has different image in y, which says that f is 1 1 function. So after making this diagram, you have to write that different elements of x has different images in y, so f is 1 1. Now for onto, the different elements in y has a different images in x, so f is also onto. Now you proved that your function is 1 1 onto. This is a bijective function, hence its inverse exists. So let's find f inverse. So what will be f inverse? So let me just write f is what? 1a, 2b and 3c. So their inverse will be, you need to invert the position. That means it will be a1, b2, c3. Now next question is to show f inverse of inverse is f. So again you need to invert. So f inverse of inverse. So again you invert this. So 1a, 2b, 3c, which is what? F only. So hence proved. So such type of algorithm you have to use in this question. Let's do another one. Now please see here. See, you are given with one. I'm reading question number 2nd. Let S be, you have a set which is 1, 2, 3, and we need to determine that the function from f in S to S defined below are inverse or not, and we need to find f inverse if it exists. So the question is f is equal to, I'm taking the second one, 1, 2, 2, 1, 3, 1. I already told you, draw the diagram, that will help you really very nicely. So 1 and 2. Here 1 is related to 2, 2 is related to 1, and 3 is related to 1. Okay, so here we can see that the different element must have a different image in this set. So from here what can we say, that as it is not satisfying the onto function definition, 1 1 function, and even onto also. So at last you have to write it is not satisfying the, it is not, f is not 1 1 and onto, hence it is not a bijective function. Also its inverse will not exist. Okay, so likewise try to see the rest questions. Okay, I'm taking this one, question number 5th one. Okay, let R be the set of all real numbers. Show that f in R to R defined by fx is equal to, okay, I need some space for this solution. Let me just rub it first. Okay, now please focus on this question, because such type of question will be asked to you in examination. Okay, so the question is, our function is in R to R. This R is a real number, and our function is fx is equal to 4x plus 5 is invertible. That means they are saying that, is this function the invertible one? If yes, then find f inverse. Okay, so this is a question mark I need to use here. Now there is a proper algorithm, there is a proper process that how to find the inverse of this fx. So first we need to prove that this function is invertible, then only we can find f inverse of it. Okay, so for this what we are doing, to just prove that this function is invertible, we need to prove that it is 1 1 function and it is an onto function. I hope these things are getting clear to you. So now how theoretically we will solve it. So the proper steps, like let there are two elements x1 comma x2 belongs to the real number x. That means we are taking a set. From this set I am taking two elements. We always have to take two elements, x1 and x2, and in this function we need to put x1 and x2, and we just need to check whether x1 is coming equal to x2 or not. So how you put here x1, so 4x1 plus 5 equal to 4x2 plus 5. This we have to do. That means whatever the function is given, in place of x write x1, and in place of again this x, x2, and equalize it. After solving this we must get x1 equal to x2. If we are getting so, it is a 1 1 function. So as you can see, this 5 with this 5 we can cancel easily, and this 4 with this 4, and hence we will get x1 is equal to x2. So from here we say f is 1 1 function. Can we understand with some example? Okay, if I take a 1, I'm getting 9 here. If I'm taking 2, then 4 to 8 plus 5, 13. I'm getting 13. So for every value which I am giving here of x, I am getting some different image. So different element have different image. So practically also we solve like this. So but theoretically this how we have to do. Now for this is for 1 1. For onto function, what we have to do, see, we know onto means we have to go in reverse order. So what we are doing, we take y is equal to 4x plus 5. From here you convert this equation in terms of y. This is in terms of x right now. Convert this in terms of y, because now we are going in inverse. So we have to do accordingly. Take minus 5 here, so y minus 5 equal to 4x, or x is equal to y minus 5 upon 4. Now for onto, what you have to remember, can you tell me what will be the domain of this function? So you will tell me the whole real number, because there is no such thing in the denominator, and as well as there we don't have any root thing. So here the whole real number will be accepted. Can you tell me what will be the range of this function or the domain of this function? It is also the same. That means it can also take the whole real numbers. So as if you can see that here fx, here you have the whole real number as a domain, and here also if I talk, here also it is the whole real number. So that is why from here we say that x belongs to real number and y belongs to real number. So f is onto. Okay, so f is onto. Now if f is 1 1, f is onto, hence f is a bijective function. So its inverse exists. Then after that, what will be f inverse? This is already the f inverse. Can you see this? Okay. No, for onto, wait, one more step you have to write before this f is onto. Please do one more processing. See, you got x is equal to y minus 5. So here you put the value of x. So y minus 5 upon 4. Here you put 4 times of y minus 5 upon 4 plus 5. So you will get this 4 to this 4, y minus 5 plus 5. You got y. Okay. So f of y minus 5 upon 4 is equal to y, which proves that it is a onto function. So please do this also, right? F is onto, then hence it is a bijective function, so its inverse exists. Then you have to find f inverse. So f inverse you already got here. See, this is nothing but your f inverse. In terms of x you have to write, this is in y. So at last, if your f is in r to r, then only you have to change your in place of this y you have to write x minus 5 by 4. This is your f inverse, because we are totally dealing with in x. Also here only we just considered y, but they need f inverse, and f is in r to r, and here your function has x. So at last y minus 5, this y is replaced by x. So remember this thing. So I hope this question is clear to you. Okay, let's do some more questions. Now let's do this question. It says if f is in a to a, where a has a domain of r minus 8 upon 5, that means whole real number except 8 upon 5, and the main function which is given to us as 8x plus 3 upon 5x minus 8, and it is very compulsory to say that the domain of this function should not be, this denominator should not be 0. That means 5x minus 8 not equal to 0, or x is equal to 8 by 5. So that is why they already gave us. To show it's 1 1, I am writing 1 1 like this, and onto function, and hence if it is so, then find the f inverse. Okay, so let's start. Let's take our function fx. Now for 1 1, I told you, if you are remembering, then you must know that we need to take two elements x1 and x2. I'm not writing all these things. So taking x1 and x2, two elements which belongs in this set A. Okay, so let's put and equalize them. That means 8x1 plus 3 upon 5x1 minus 8 equal to 8x2 plus 3 upon 5x2 minus 8. Is this clear? So take this term here. So you will get 8x1 plus 3 times of 5x2 minus 8 equal to 5x1 minus 8 and 8x2 plus 3. Now what you have to do, you have to multiply. Now this will take some 2-3 steps, and let me tell you, here at last you will definitely get x1 equal to x2. Okay, so I request to you to please open the brackets, solve it, whatever the things are cancelling, just cancel, and at last you will get x1 equal to x2. That is for sure. So from here we will say f is a 1-1 function. So this work is over. Now for onto function, what we have to do? We consider y is equal to 8x plus 3 upon 5x minus 8. This is y equal to fx form. We need to change it into x is equal to fy form. So this is in terms of x, we need to change it in terms of y. So take this term here. So y times of 5x minus 8 is equal to 8x plus 3. Now multiply this y inside. So 5xy minus 8y equal to 8x plus 3. Okay. Now take this minus of 8y there. Okay. And this 8x here. So 5xy minus 8x is equal to 8y plus 3. From here take x common, you will get 5y minus 8 is equal to 8y plus 3. Now x will be 8y plus 3 upon 5y minus 8. So here we converted into x, here we converted this equation in terms of y. Now from here, can you tell me what will be the domain of this particular thing? So you will tell me the denominator should not be equal to 0. That means 5y minus 8 not equal to 0, 5y not equal to 8, yeah, y is not equal to 8 by 5. Can you spot one thing, that for this function the domain was r minus 8 upon 5, and for this function also the domain will be the whole real number minus 8 upon 5. As their domains are same, okay, that is why what we will write here, one more thing, okay, I forgot, f of x means this 8y plus 3 upon 5y minus 8. In place of x, that means 8 times of 8y plus 3 upon 5y minus 8 plus 3 whole divided by, in place of this x also, 5 times of 8y plus 3 upon 5y minus 8 minus of 8. Take the LCM, multiply this 8 inside, here also cut the denominator. Your final answer should be y. If it is y, so clearly and very precisely you can say that it is a onto function. So hence f is 1-1 and it is onto. So finally we can say it is a bijective function. So inverse exists. And I already told you this is nothing but this step is your inverse one. So you say f inverse is 8x plus 3 because it is in the same. So 8x plus 3 upon 5x minus 8. This is the inverse of it. I hope this is very clear to you. The algorithm, the process of solving, the same process will be applied in all the questions. Okay. If you face any problem, please don't hesitate. Let me know you are getting any issue in the further questions. Okay. And if possible, we'll take some more questions if you ask the doubt to me, and otherwise we'll start with the binary operation, which is the last topic of the chapter. Alright, so I wish you'll do the questions. Okay, so do a good practice. Just see the examples how to write properly here. Alright, so let's meet in the next lecture. So till that, thank you so much. Have a nice day and do practice. Thank you.